Hello. Today's session we're going to look at GeoPandas, which is a way of producing maps within Python that is based on top of pandas data frames. Previously on this course you've looked at QGIS. This is another way of doing something similar. This module is standalone, so while knowledge of QGIS will help you understand some things that are faster, like projections, you won't need that for this module. So QGIS or GeoPandas, and the choice of when to use each, it's going to be largely personal preference. If you're very much used to one, that's going to be your first port of call probably. But they do have different strengths and weaknesses, I think. I find QGIS very good for exploring maps, zooming in and out and panning around. It's very efficient and nice to use for that. And it can produce good quality, very good quality maps as well as output. GeoPandas, though, is probably a better choice if you want to produce a series of the same maps for multiple scenarios, for example. That you can automate stuff easier with GeoPandas, I would say, than QGIS. Can be done in QGIS, but it's easier on GeoPandas. So they're complementary. It's not either or. They're both fantastic, and they're both available to us free, which is just incredible. Okay, so we're going to look at GeoPandas. And we want to start at this website, github.com, Michael Allen 1966 /2010 _ GeoPandas. So if you navigate to that website, and in this first session, what we'll look at is either running it on the web, which you can do, so you don't need anything installed locally for this if you don't want to, or we'll also look at how to install an environment locally. Do not try to install GeoPandas on top of your normal Anaconda base environment. It is very likely to break your base environment, though you may not notice that until you try to use it for something other than GeoPandas. Okay, so we'll navigate to this website here. So Michael Allen 1966 /2010 GeoPandas on github.com. And first of all, let's look at the way we're going to, you can run this on the web if you want. And that's, if you just look down here in the README file, you'll see something that says Launch Binder. And if you click on that, that will take you to mybinder.org, and it will start saying starting repository. What it's going to do is set up an environment on the web in mybinder.org. Now this may take up to 5 minutes if this repository hasn't been used for a while. So if it appears to be slow, you may want to go and get yourself a cup of tea or whatever. If it has been used recently, then it should remember the environment, so it doesn't have to set it up all over again. So I'm just going to leave that for a second running. I'm going to pause the video and wait for it to set up the repository. Okay. That took just about a minute or so this time, because it had been used quite recently. So this has opened up a Jupyter notebook on the web, and we can see here are the notebooks in there, and we're going to want to use GeoPandas _1 blank. So just click on that, and it opens up a notebook on the web, and we'll use this actually to run through things, I think. Okay. I'm going to go back to the GitHub repository and just show you how you will set up an environment if you wanted to run things locally, which you're going to want to do if you're going to want to work on your own your own data. So, best thing to do with GitHub repositories is to download the whole lot normally. And so if you go to the green code sign here, those of you who want to get into using GitHub a lot, then this SSH secure shell is the nicest way to do it. If you're familiar with that, obviously go down this path. Otherwise, if you download the zip file, okay, now it's downloaded the zip file. If I go and find that, that's going to be in my downloads here, 2010 GeoPandas main zip, and I'm going to extract that. Obviously, how you extract zip files will depend whether you're using Windows or Mac, or in this case, Linux. So if I look in there, here are my notebooks, and here's everything I'm going to need for this tutorial locally. And BinderHub, where it was running before, was looking in this folder here. And if you want to set up an environment locally, you want to navigate into Binder, and we're going to set up this environment. This is called a YAML file, yet another markup language. And there's some install instructions here as a text file. Though normally all environments tend to be called environment here for the YAML file, so you sort of soon get used to doing this. Now you want to go into a terminal. Now if you're using Windows, you want to go into Anaconda Navigator probably and select Anaconda Command Prompt. We may be able to get to that directly from the Start menu. And then you're going to navigate to where this environment file is. Oh, if you're on Mac, if you click on the Rocket Launchpad, start typing terminal, and it will launch a terminal that looks very much like this. So I'm going to find the directory or folder that I want, and I know because I can see it there. I'm in Downloads. Most terminals have tab complete. If you start typing, it will find what you want to do next. 2010, and then I want to go into Binder. Okay, so now I'm my terminal, my Anaconda command prompt, if you're using Windows, will be here. Then I'm going to say conda, and it's going to be an environment command, create from file, and then I'm going to create environment.yaml. Let me just put that all on one line, make it a bit clearer. So the flag -f tells it to look for an environment. Now let's have a quick look at that environment just to remind you. Hopefully you have looked at the video on environments, but if we have a look in that, what it says is what it's going to call the environments, where to look for the packages, and what are the things that you want to install, what it calls the dependencies. So we've got GeoPandas, Geoplot, GPythonLab, PyCell, Python, a slightly older version, pip, and then using pip it's going to install two more packages. The first one I can never say without getting my tongue all twisted. Let me try. Contextily. It ought to be easy, but I keep tripping over that, and map classify. So the environment is telling it what to install and what versions. You don't need the version numbers. Conda will go and find it, version numbers, if you want, but it's faster if you give it the version numbers. Okay, so I'm back here. I'm going to hit return. That's going to go away. Oh, it already exists. Sorry. Okay, so I'm not. I did one earlier. So if you do that, it will rattle through installation, except with GeoPandas it probably won't rattle through. It may take up to 5 minutes. But you only have to do this once locally, and then that environment is always there. Okay, now we're going to want to activate our environment, and you can do that from Anaconda Navigator. You can go in and select an environment, or I prefer it to do it from the terminal. And I'm going to go back, let's open a clean terminal. I'm going to activate Conda activate GeoPandas, and slightly annoyingly there's no tab complete. If you can't remember what your environment's called, Conda env list, and this will list all of the environments that I've got. So Conda activate try to tab complete that, GeoPandas, and there we are. And we can see in our terminal I've gone from Anaconda base to GeoPandas. Just to reiterate, if you're doing a project, it is always best to set up a new environment for that project. Stops you breaking the base environment that you might be using for other projects. Don't try and do everything in a single environment. Except we all do, and then we all find out why. That we break things for not only the project that we're doing, but for all other projects as well. Okay, so GeoPandas. Now I'm going to enter Jupyter Lab, and you can, this might be in your Windows Start, however you normally do it. I type Jupyter Lab, and here I am in Jupyter Lab, and the menu starts at where I went into it, which was in my home file, and I'm going to want to navigate to where I have the files. So let's use the ones that we actually downloaded. So under downloads, GeoPandas folder, and then I'm going to open up GeoPandas 1 blank, and let me close that. And so there we are. So what we can either go in via GitHub and go to BinderHub if you want to run this tutorial on the web, or we create our own environment, activate that, and then open Jupyter Lab. Right, just pause there for a moment and we'll come back and start going through this. Okay, let's get going. So either, hopefully you've got it open on the web, on BinderHub, or you've installed your own GeoPandas environment and have opened up the notebook from there, but now we're in Jupyter Notebook and ready to go. So what are we going to go through? GeoPandas installation, we've already done. Then we're going to look at creating a GeoPandas DataFrame from a standard geographical file format, which will be shape files. So in this case, we'll start with. So they're areas. We'll also bring in some point data later. Setting the accursed CRS, coordinate reference system. This is the thing that if you get it wrong, you find you've moved Devon somewhere close to the Azores. But here it's some ways I think this is slightly easier than QGIS because it's a bit more explicit. Then we're going to look at creating a map from the GeoPandas data frame itself, very simply, very quickly, just from a data frame. Show me a map of it. Then we're going to sort of combine areas together. So if you've got a lot of, in our case, lower super output areas in accounting, we want to kind of merge it all into one, and maybe we want to average the data or whatever. We can merge, Then we're going to look at, well, how can you select out a small area within a larger area? So if you've got all detail for the country and we just want some detail for Devon, how do we select that? We'll look at handling point data. As we go through this, we'll be converting between British National Grid, BNG. If you see that, that's Eastings and Northings. So that's how far east and north you are in metres from a reference point, which is somewhere off the west coast, somewhere. And the sort of worldwide convention of latitude and longitude. And we'll look at how you can really start to customize your maps with Matplotlib, so you can produce very high quality maps, very customizable. Okay, so let's get going. I'm going to start with the zip file. That's what you started with, QGIS. And for this, I took one from the government site for all of England and Wales, and I've just very quickly clipped it to an area that's somewhere in the southwest. So it's not a precise collection of anything. So we'll want to then pull out Devon and Cornwall areas. That's all saved in the repository for this notebook. So if you've downloaded the notebook or if you're running on the web, you've got all the files you need. But if you want to find the original files, Google is always your friend. The government have a nasty habit of moving them around. They're not very stable, or haven't been in the last few years, of where they put stuff. I've put a link here to where it currently is in, where are we? October 2010. This links, hopefully, to lower super output areas is what we're going to use. So these are the populations of normally around 1,500 that the government divides us into. So they're areas of roughly equal population rather than equal size. We do a lot of our mapping because there's a lot of data available, policing data, health data available by lower super output area, or a collection of a few of those together, which takes you up to a medium super output area, MSOA. So here's the site, and you can download the data here in various formats, and we will normally be using shape files. Okay, but you don't need to do that for this tutorial. That's done. So installation, we've been through. This also just tells you a bit about the packages that installs, though we saw that in the environment file. Okay, so as with most things, we tend to put all of our inputs normally at the start. So we input our sort of modules and packages here. So shift enter. And that's loaded up everything we're going to need. Now we're going to load our shapefile, which is in the form of a zip file. You may just have the shapefile SHP extension for some things, and that's fine. You would just load that up. But frequently shapefiles are zipped, compressed, with some other metadata about them as well in the zip file. And both you would have seen in QGIS, you can load up the zip file. Similarly in Pandas, we can just load up the zip file. Now let's mention coordinate reference systems. So the coordinate reference system is how it's going to locate a point on a map. Now there are, actually I don't know how many of them there are. There are lots of them, but when we're working with British data, we tend to use just two different ones, which makes our life easier. The first is, annoyingly they also have two names. So the first one we know as EPSG 27700, isn't that great? But it is also known as OS Ordnance Survey GB 1936, and it's the British National Grid system. So this is the Eastings and Northings that we're going to use. The other system is the WGS84, the World Geodetic System 1984, and that is the longitude and latitude standard that's frequently used for worldwide mapping. So these are the two we're going to use, and generally speaking, if your data is in lat long, I say lat long because we always do, but nearly always we're going to want to import longitude. It expects longitude first and latitude second. And if you get those mixed up, you can also end up with Devon and Cornwall somewhere off, I think, the west coast of Africa. So these are the two systems we're going to use. Lat long use WGS84, and if you're in the British National Grid, then you use OSGB 1936. So we're going to import our shapefile, and the shapefiles come with British National Grid geography. One common thing, okay, so this will be in the metadata in the zip file. You can always just try the different ones and see how it works. So we're going to give it the file name first of all, and tell it that it's going to be a zip. And then we're going to use GeoPandas read file. So GeoPandas is our imported module, read file is our method, and we give it the file name, and we also give it the CRS, and we tell it it's going to be the British National Grid CRS. And we're going to load that into LSOA underscore GDF, I've called it. So just to let me know that's a GeoPandas data frame. It's going to behave very similar to a normal pandas data frame. So let me load that. And then we can use a lot of the standard methods for pandas on GeoPandas. So I'm going to dot head, open close brackets, is going to show us the top 5 records. If I only wanted to say the top 3, for example, or I could put in 10, I'm going to hit that there. And now we see what's in this data frame. So it looks very much like a normal pandas data frame, except it's also got this extra column called geometry. And it knows that that is a very specific thing that's going to handle geographic data, and it knows, because we've told it here, that the points that it refers to are using British National Grid. And we can see each area, so this is a lower super power area, this one is in Bath and North East Somerset. We've got its area in hectares, in case we care about that. That just seems too high. And then that's the lengths around the outside. I don't think that's calculated right. And here's our geometry, and this is a series of points held within actually a tuple, that it will be the longitude and latitude, no, Eastings and Northings for each point going around the outside of a shape. So that's in our geometry field, our geometry column in our GeoPandas data frame. Okay, so let's just have a look at, see if we can plot this. And very simply, we're going to give it our data frame name, and we're going to say plot. And we don't have to give it a fixed size, but I have done then. Semicolon at the end, if you see that, particularly in Pandas data frame, it just suppresses any sort of extra information it wants to give you. So sometimes it just sort of tidies it up, because otherwise it might say, well, let's look at the difference between the two. Let's not have the semicolon there, and we're going to plot that. And here's our map. This is just a very simple one, but we can see here are our Eastings, and here are our Northings, and it has plotted all of the areas in our data set, and the boundaries are the outsides of the LSOAs. Now GeoPandas does something quite nice in that we've said fig size 8, 8. So you could say, well, that would give us a square. But if it made a square, it would pull the geography out of proportion to what it should be. So what it uses this 8, 8 for is that's kind of the maximum size. So if I did 10, well, let's do a small one, 4, 4, my output's going to be smaller. Let's go back to 8, 8. But it will shrink one of the axes to make it fit our actual data. Now, the only difference between the semicolon at the end that we had and not is it's put this axis subplot if I don't do that, if I don't have the semicolon. So semicolon just suppresses this sort of output. So enter, there we are. There's our map of Devon and Cornwall and bits of Somerset. Though we didn't include Bristol, so this is an area we sometimes call Bosnia, bits of Somerset. Devon, Cornwall and Bosnia is bits of Somerset, not in Avon. Not sure they appreciate that in Somerset, but anyway, there we go. Okay, I'm going to pause here, and then we're going to move on to selecting data. Okay, on to the next bit. What we're going to do now is select data that comes from Devon and Cornwall. Now this isn't in our original data frame. There's nothing in here that says Devon and Cornwall. So we're going to bring in some more data. This again comes originally from the government, but it's all supplied locally for you. Let's have a look at it. It's shape files of counties and unitary authorities in England. Yeah, I think it's just England. So we're going to do exactly the same. We're going to give it the file name. It is a zip file, so we tell it. Things like this, you know, not expecting you to remember what to do. Here it is as a reference, and then you just copy and paste this type of thing and change what you need to. I split the line here using the standard Python plus, just because to get it on, stop it spreading wide across the screen for you to see. We'll check in a second what that actually looks like, the file name, in practice. So we build the file name, which could be a single line, and then we're going to load it into Counties Geo DataFrame. We're going to use the GeoPandas read file again, and we're going to then set the coordinate reference system. So this is using it just slightly different to before. Before we put the coordinate reference system here. This is doing the same, just to show you can load the file and then later set the CRS. So let us do that. Load up the file. I'm just going to add an extra line in here. Let's just have a look what that file name has done. And this sort of plus Python, it's 2 strings, and it just simply joins them together. So this 2017, it then has this looks like double underscore here, boundaries UK string afterwards. So let's have a look at this counties.gdf. That actually should be head. Open close bracket. If we don't give it the number of rows, it will default to 5. Now what we've got is we've got a new GeoPandas DataFrame, and county and unity authority name, some various information around it, but what we're most going to be interested in is its geometry. And just as we did before, we can plot that, and we can say, oh, it's the whole of the UK. So this gives the boundaries around each county or unitary authority. And so around us in Devon and Cornwall, Devon is a county, but it doesn't include Torbay Unitary Authority and Plymouth Unitary Authority. So we're going to have to search not only for Devon, but those unitary authorities as well. The way we're doing it here, we can't zoom in and out as we could in QGIS. So that's an advantage of QGIS over Pandas or GeoPandas. We could adjust the sort of zoom in areas here, but you haven't got that simple zoom in and out. Okay, next bit, we're going to be using Lambda functions. Now, you can just copy and paste this, but I would recommend Lambda functions are used quite often, not very often, but they are useful, particularly in Pandas DataFrames, when you want to map a function across all your rows, whatever. So what I recommend, everything is voluntary here, it's completely up to everybody, how much they want to look into or not look into, but I do actually recommend that you take a break and at this point watch. It's a 6-minute video on YouTube. These are great, by the way, Socratica Python videos. They're all 5 to 10 minutes long. They take just one component at a time, and they're quite entertaining if you kind of like their sense of humour, which I do. Anyway, here's 6 minutes on Lambda functions, so I recommend you have a look at it and enjoy. Okay, hopefully you've enjoyed that short video on Lambda functions. So we're going to apply that next, because what we're going to do is we're going to take this map, which contains the geographic boundaries for each county, and we're going to identify those in Devon and Cornwall, and then we're going to combine them into a single area, and that becomes useful then for later on if we've got national data or other data and we want to say, I just want to use the data that's in this area. It gives us one single combined area that we can ask of other data, are you in this area of interest for me? Which we'll see as we'll go through. So, finding Devon and Cornwall data, we're going to use a Lambda function, which hopefully you're now familiar with, and we're going to use a map method, which in Pandas or GeoPandas, what that does is simply apply a function to every single row in a Pandas or GeoPandas data frame and gives you the output of applying that function to each row. So it's kind of the same as going through each row in a for loop, but it's more efficient than doing it in a for loop. So here's our method. We're going to create a new output, Devon and Cornwall, and we'll see that will actually be an output for each row, and it'll be in the form of a Pandas series, which is like a data frame but with only one column. And we're going to map this function to each row, lambda x in Devon, Cornwall, Plymouth or Torbay. And the thing that is passed to that function, what x is, will be the value of this field, County and Unity Authority 17 name. So let's do that and look at the output. So it's effectively done a for loop with, for each row, take that field and pass that as x to a lambda function x in Devon, Cornwall, Plymouth or Torbay, and it gives us an output as a pandas series, length 217. So for each county, whether in the county's GeoPandas DataFrame, which was the geographies of every county, whether that row is a Devon and Cornwall row or not. So if we, let me just put in a new cell here. Cells you can insert. Can you do it in here? Edit. No, just looking. I always do, if you press escape, then A inserts a cell above and B inserts a cell below. I'm sure there's another way of doing it from the menu, but anyway. So if I do Devon and Cornwall, and I can do a sum on that, with a bit of luck I've got 4 rows, because I know there should be 4 rows. Yeah, so there are 4 rows in there where the value is true. Now I'm going to add that column in as a new column into my county's GeoPandas DataFrame. I could have done this all in one go, but I've broken it out here. So I'm going to add that in. So now if I look, my rows now will have, this is my county's data frame. We've got this new column now, are you in Devon and Cornwall? False or true. And then just to remind you that we can do normal pandas data frames. So if I want to say, well, I just want to see which rows actually are Devon and Cornwall, then let me do this kind of in individual steps. It's quite often useful to think of things as I want to apply a mask, and the mask is counties data frame, and then I'm going to want Devon and Cornwall is equal to true. Now this is a true and false value anyway, but you know, this could be is greater than 5, less than 5 or whatever. And then if I looked at my mask, it would be a sort of Boolean of true and false, whether a particular row meets a particular condition. And then if I want to look at the ones that are true, you might think I put in my mask here. This won't actually work, because when you put in a reference after the data frame in square brackets like this, by default it looks at the columns and not the rows. If I want to look at the rows, it's actually .log, which is not an immediate name that you're going to remember. It's just something that when you use pandas a bit, you get to know. So now I get a new data frame. It hasn't amended the original. In fact, here it just puts the output, and it's applied that mask, and it has shown just the rows here that are in Devon and Cornwall. I could have given that a new name, so I don't know, DC equals, and then I could have done DC. Have a look. And now I've got a new restricted data frame. Okay, so sometimes that might be all I want to do. What we want to do now, and we'll just merge together and then have another virtual break. What I want to do is, instead of pulling out the rows by whether they are Devon and Cornwall or not, I want to take this original data frame and I want to merge all the rows that are Devon and Cornwall into one, and equally all the rows that aren't Devon and Cornwall into one. And I could do it by any other thing. It could be that counties were labelled A, B, C or D or whatever, and I could merge all those that were A together and merge all those that were B together. And that's actually called a dissolve method. And there's some help on dissolve here. I'm going to create merged GeoPandas DataFrame equals counties, the geo data frame, and I'm going to dissolve by Devon and Cornwall. So the Devon and Cornwall, to remind you, we added this to the geo data frame and it's true or false. So in this particular case, when we dissolve, the output will be 2 rows because it's either true or it's false. If you were dissolving by a column that had 10 values, you'd end up with a data frame with 10 rows. Okay, so let's do this. Now, if you're on, this can take a little while sometimes on some computers if they're a bit slow. So I'm going to have a quick glug of because what it's doing is it's finding all of the counties that are Devon and Cornwall. Well, that's pretty easy. Or finding all the counties that aren't Devon and Cornwall. For each, it knows the boundary of each county. And what it's doing is it's working out now the boundary of all of those that are merged together. So in the case of the ones that are not Devon and Cornwall, you know, there's 100 and I don't know how many. Was it 180 counties or something like that? Anyway, so anyway, more than 100 shape files, or the shapes, the boundaries it's going through and finding the outside. Let me just pause this while that carries on. Okay, that took just about 30 seconds more, but it might be slower depending on your computer. So it's created a new GeoPandas data frame, and it's got 2 rows. Now this is the index. This is the index column. So in our case, it's false or true. If you were dissolved by something else, then it's whatever the values of the column you dissolve by will come out as the index here. And it's actually created a new geometry, and you can see, you probably don't remember before, we had a polygon. We've now got what's called a multi-polygon. So it actually knows now, in here is stored all of the individual ones as well. Now we're going to want to select just what we're interested in is getting the geometry of Devon and Cornwall. So Devon and Cornwall geometry equals merged GeoPandas data frame .lock. The .lock is because we want to select rows. Then we put what rows do we want to select in, and in this case it's going to be just simply the row that is true. And we're going to put out just the geometry field because that's what we're interested in. Okay. Now, this is a GeoPandas geometry, and GeoPandas knows that it is a geometry field. It already knows also the coordinate reference system. And so if we plot a geometry table like this, or object like this, if we just say DC geometry in GeoPython Notebook, very nicely it gives us a map of what the area that is Devon and Cornwall. So now we've got what we've done. Let's just recap what we did to get there, because now we're going to use this to sort of filter out our other information, because this is our area of interest. So let's just recap what we did. We pulled in our map of counties and unitary authorities. We then found, and each of those has a name. We found the rows where the name was, and the name is stored in County Unit Authority 17 NM name. We found those rows where the value of that is present in the list Devon, Cornwall, Plymouth, Torbay. So that gave us a whole lot of false or trues, which we then put into our counties GeoDataFrame. So our counties GeoDataFrame now had an extra column of whether that row is in Devon and Cornwall. Then we looked at it manually by creating a mask. Mask is often a nice thing to do in NumPy and Pandas. If you're trying to think through a search, do it rather than applying it all together, particularly to begin with. It's quite good to think, well, what's my map? What are the rows that I want to show? And that common nomenclature, if you look in books, it's often will be called mask. And so here we defined our masks and say, well, our mask are those ones that are true in the Devon and Cornwall, and then we looked at the rows that we wanted by applying that mask. And if we want to look at rows, we do .lock. If you do, by the way, just .ilock will use the row numbers rather than the index names. So .ilock 0 will be the first row. .lock looks for the index names. So here we apply the mask and we show there are four rows of that. Then the next thing we did was to use the dissolve method, which combines areas together into fewer rows, and it creates an outer geography as well, outer geometry for the areas. So we used the dissolve method for reducing our rows in our data frame. That we created a new data frame into, are they in Devon and Cornwall, are they not in Devon and Cornwall? So we have our merged data frame, and then we pulled out the geometry field just for Devon and Cornwall. So now we have our Devon Cornwall geometry in its own object, and then if we just sort of in GeoPython notebooks say, well, what's the value of that, if you like, because if this was a variable that was 10 or 11, it would show us that variable. It knows to show us a map of the area that our geometry covers. Okay, time for a break, I think. Go and get yourself a cup of tea, have a good stretch, walk around, and see you back in a bit. Okay, so now we've got our single geometry field, or geometry object for Devon and Cornwall. We're going to use that to select, if we go back up to our original data, those LSOAs, we're going to find those that are within our restricted Devon and Cornwall. So it's going to eliminate just sort of clean up the data. So you might use this technique where you're given a whole lot of data that includes the area you're interested in, but also has other, and you want to find just those that are in the geographic area of interest. So we've defined our geographic area of interest with our Devon and Cornwall geometry. Now we're going to apply something called a spatial relationship, and there's a Wikipedia page here on spatial relationships. And so just very briefly, there are different formalized names. So just taking the top here, A is a space, an area within B. A touches B. And we're also, I mentioned crosses, we're also interested in crosses, that our area A and B, at least part of A, sort of is in this area that's one side of a boundary line. So that's crosses. And the Wikipedia page gives a sort of more formal definition and some other closely related names. So we're interested in all the LSOAs in Devon and Cornwall. Now, to begin with, I used just within. I said, find all those LSOAs within my geography here. But I found it actually missed some on the boundaries between the counties. And so I found I had to do within all crosses to get them all. And now in pandas, to use an or an and, you use stick, which is, if you've got a standard keyboard, will be on the key to the left of Z for or, and it's quite a common symbol for or, and you'd use an ampersand in pandas. So what we're going to do is create a mask again. So again, we're doing this sort of two-step. Let's create a mask and then apply our mask. In fact, I'm going to let me put that in a different cell down here. Okay, which in your version it should already be separate, because I'll save this at the end. Okay, so our mask is going to be, does our LSOA in our data frame there, it's going to get all those rows that overlap with our geometry here, or stick, get those rows that are within our Devon and Cornwall geometry. So I'm going to hit this. I'm going to pause the video because these geospatial things can take a minute or so to run, especially depending on the speed of your laptop. So let me run that. Okay, so that's run. It's produced a mask. So if we have a quick look at that, and what we've got again is for each row in our LSOA geodata frame, whether it's true or false of whether it met these conditions, that it was either overlapping or within our Devon and Cornwall geometry. So now we want to apply that mask. I just checked. Before I said if you're using rows, you should always use lock, and if you're selecting columns, you don't use lock. I would still say that, of course I would, because I said it before, so it must be right. But I just found when it is a series like this, it will actually understand that if you don't use lock, that it is applying a mask to the rows, because it's a data series, pandas series that matches the data frame. But I'm going to insist on right. To be clear that you're using selecting rows, I would use .lock. Okay. So now, if we look at our Devon and Cornwall LSA, so we've created a new data frame here, or geodata frame, GeoPandas DataFrame, by taking the original ones and just applying the mask to see which ones we get. So if we look at that, then it looks identical to our original LSOA DataFrame, except now we've only got those that are within Devon and Cornwall. So if we plot this as a map, we can see this one's LSOAs, so we can see all our individual LSOAs, but now it's cut off anything that's not in Devon and Cornwall. So we have a new restricted, tidied up data set, if you like, to work with. Okay, let's pause there, go back over that section and have a look at it again. And then the next step, we are going to load up some point data in Devon, apparently. I think I might correct that while you go and have a cup of tea. I'll check over my spelling, which, as ever, is mysterious even to me. See you in a moment. Okay, we're getting there. So we've got our LSOAs that are in Devon and Cornwall. We've got them in their own GeoPandas DataFrame, and we got them by applying some nifty spatial relationships, which you can see they're very versatile and flexible. So next thing we're going to do is bring in some hospitals. So this is point data. It's got an X and a Y of where the hospitals are, and we're actually using those hospitals that are acute stroke units, just because, well, that's what I'm interested in. Now, our point data happens to be in a CSV file that does not use Eastings and Northings. Rather, it uses latitude and longitude. So we're going to bring it in, and then we're going to initially set its coordinate reference system to EPSG 4326, which is WGS84. So remember, actually, most of the time we're using one of two coordinate reference systems. One is if we're dealing with British National Grid, Eastings and Northings, and the other is if we're dealing with lat long. So let's have a look at this. So the data here is, if you downloaded the zip file, it's already there. And we're going to read it in as a GeoPandas data frame. None of the sort of zip business here, it's just a comma separated file. Then the next thing we're going to do is to set a geometry field. So this CSV, though it has latitude and longitude, it doesn't specifically have a geometry field to it. So we're going to create one, hospitals.geometry, and we're going to use the GeoPandas method points from X, Y, and we pass it what the X and Y are. And our X, and this is where it's easy to get it the wrong way round again, because we tend to talk of lat long, but we tend to then actually always import, or talk of XY and import longitude and then latitude. But we import, we say, what is the X field? Well, we've imported it in our hospitals geodata frame, and it's the column that's called long, and our Y field is in our hospitals data frame, and it's the column that's called lat. So these are the column names, long and lat. Then we're going to set our coordinate reference system to tell it, well, what do they mean? Where does that put them on the world? And we're going to use set CRS, and we're going to do it a slightly different way, again, just to show you the different ways. And we're going to say EPSG equals 4326, which is our lat long coordinate reference system, WGS 84, otherwise known as EPSG 4326. Why do they have so many different names? Anyway, we set it, and then we'll have a look at it. Okay, so that's done all of that. So this is our data frame, so it's imported. So these are the columns. So in the original data frame, well, let's have a look at it. We can go to data, and GeoPandas notebooks can open up. Which one did we use? 107. Can open up CSV files, and we can see, so this is what it imported. Hospital, that's going to be postcode, and our columns, latitude and longitude, and some other information about it. So this came from the CSV, all of this, and then this is the geometry field which we created. And now, rather than saying polygon, it tells us it's a point, and we can see the point brackets there, tells us it's a sort of tuple, and that is our longitude and our latitude for each one. So good, that's important. But now we've got a slight problem in that our area data used British National Grid, and our hospital data is using lat long. So we want to convert one of them, and we're actually going to convert this one. Could be either way round, but this is going to be quicker because they're data points rather than big sort of shape areas. And it's very easy. And this is a nice thing in GeoPandas to be able to do, and I think it's more explicit than working with QGIS. So we're going to say our data frame equals our old one, and then we give it the method to CRS, and we give it the new coordinate reference system to use. So 27700. That's the British National Grid, Eastings and Northings. So we do that, and then if we have a look at it, it's the same table, but our geometry, the point coordinates have actually changed. So here, the first one is 0.17, that's its longitude, and 51 is its latitude. Now we have 5511118, which is the Eastings, how far east in meters it is from our reference point, and 187777, how far north in meters it is from our reference point in the British National Grid. So we've taken lat long and we've converted to British National Grid very, very simply. I think that's lovely, that. Okay, now things starting to get hopefully a little bit familiar in that we've got a whole lot of hospitals. Let's just, I haven't actually tried plotting this. Hospitals.plot. Let's just see what it does. Okay, so that's they're all the acute stroke units, and actually you can see the outline of England here and where they are. Axis subplot, if we wanted to get rid of that, just remember we just put a semicolon to tidy it up a bit. Here are our Eastings now and our Northings, and these are the hospitals. We're only interested in those of them which are within our geography interest, a field of interest, which remember we call DC geometry. So these are all going to be within, though we can always check that. It's always worth checking these things, you know, does it give us the hospitals we expect? So we create a mask. Mask is hospitals, the data frame within our defined geometry, and then we apply that mask dot lock to make it clear that it's a row, though it looks like it would actually work here. And then we'll have a look at DC hospitals. Okay, so now we've got, it's the same table as we had above of all the hospitals, but now it's limited to those in Devon and Cornwall, the acute stroke units. So we've got Barnstable, Plymouth, Derriford, Truro, RD&E and Torbay. Okay, let's pause there, have a look at that bit again. So what we did was, to recap, we loaded a CSV file, and we can look at our CSV file in GeoPandas Notebook. You can also do things like sort, I think. Oh no, you can't, I'm fibbing. So we loaded our CSV file as a GeoPandas DataFrame. We set its geometry from our X and Y, and we know the X is longitude, Y is latitude. Then we had to convert our coordinate reference system from latitude, longitude to British National Grid, Eastings and Northings. Oh, sorry, no, in this case, sorry, we just set it to be latitude and longitude. Then we had a look at it. And then we converted it from lat-long to Eastings and Northings, British National Grid. You will get used to doing this, and there are nearly always just these two. Lat-long, which is WGS 84, and British National Grid, BNG. And you're going to be converting from one to the other. They're very unlikely you'll have to deal with other ones, but there are other ones. And then we could see how our points were changed. Okay, and then we could plot it. It gives us a sensible plot on our Eastings and Northings. Then we use the within to get those that were within our defined geometry area, and restricted our data table to those hospitals, which gives us our Devon and Cornwall hospitals. Okay, just go back over that and just check it all makes sense to you, and then take a break, have a walk around, say hello to somebody. Okay, you're on the home straight. This is the last section, apart from an optional extra one at the end for those that like trains, because trains. What we're now going to do is we're going to bring in travel times from all the areas in Devon and Cornwall to each of the hospitals, and we're then going to bring all of our three components together in a map. We're going to have it divided by LSOA. We're going to plot the hospitals, and we're going to map on the travel times by LSOA, and we'll also apply what's called a basemap, like a Google map, but we're not using Google Maps. Okay, so let's read in our travel time data. So this is travel time data from the kind of middle centroid of each LSOA to the closest hospitals. This is something that we did separately. I think mentioned on the QGIS one, I can't remember. Somewhere probably mentioned. I use something called Routino to get travel times. That runs in Linux. You may have to pay for travel time data if you're using another method. It's estimated road travel time. It's based simply on knowing the type of roads, is it dual carriageway, whatever, and then applies a standard speed to those. So let's read in the travel time data and then just have a look at it. This is actually, we can see national data here. So we've got things in Welling and Hatfield. But the thing we're interested in is the time to the closest, well, it actually be this one, time to the closest acute stroke unit, thrombolysis unit, is what we're bringing in, we're interested in. Now, we have our original Devon and Cornwall LSOA GeoPandas DataFrame, and going to pull in all of this data, but only for those rows that are in the Devon and Cornwall LSOA. So we're going to use a standard pandas method here called merge, and even though Devon and LSOA is a GeoPandas DataFrame, the merge method from pandas will work. So you can find more help on merge here, but here you can see its syntax is pretty easy. What we're going to merge, we start off with a pandas data frame, and we're going to merge from another data frame which is called travel time. And then those familiar with databases, this will all seem very familiar. Our linking field from our left, which is original, was called LSOA 11 name. That's our LSOA name. Our right one that we're merging from, the same field is actually called something different. The LSOA name here is called area. So right on area. So this is giving it which columns to link. How equals left means just keep those rows that are in Devon and Cornwall LSOA. So we're going to do that, and then if we look at that, what we've got is our original data that we had, plus now we've got all these extra fields from the other data frame. Though the only one we're going to be interested in is time to thrombolysis unit. So this is time to the closest acute stroke unit which we've mapped. Okay, so before we've just done plotting, we've taken our GeoPandas data frame and we just said plot. Now we're going to do something a bit more versatile with matplotlib. A bit more versatile, but a bit more scary. But remember, frequently you can cut and paste. So this gives you a reference and explains what each of the items mean, whether you want to use it or not. So let's first of all show this map, and then we'll talk through what it's done. Okay. What we've got here, before we go through this, what we've got, we haven't got the hospitals yet. Okay, we're just plotting LSOAs travel time to their closest acute stroke unit, and we have coloured that using what's called a colour map in matplotlib. So anything that's bright yellow is kind of on top, you're on top of an acute stroke unit. Anything going to black, you are kind of furthest away in minutes. So it's yellow around the hospitals, so not surprising when we add the hospitals we'll see them close to the yellow, and then this area, or actually around Heartland Point, I think, you are the furthest away from an acute stroke unit. Anywhere in the country, I think. Okay, so let's have a look at what we've done to create this. So we've created our map, we've coloured it, we've added a colour bar. So first thing we do is to create a matplotlib kind of empty chart with figure ax, plot.subplots, fig size, obviously change this fig size. Again, this fig size is nice in that those will be its maximum dimensions, and it will shrink the shorter north to south dimensions to fit it. Right, column equals, this is the column that it's going to use. If you give it this, it will colour the areas that it's plotting. and the one we are going to use is timed thrombolysis unit, so the column to apply colour. This one's a bit weird, anti-aliased equals false, and if you don't have that you might just get some strange artifacts around the boundaries. Edge colour equals face. What we're doing here is for each LSOA we're making its boundary colour the same colour as itself. So it effectively hides the boundaries when they're merging together. So you don't have to have that. You can play around with these and see what they do when you change it. Now this is our scale, and you don't have to have it. You can leave it to be automatic. But if you want to, I've set these manually. It might have chosen something slightly odd. Anyway, Vmin, Vmax is the manual scale to apply for colouring, so 0 to 70. I think the reason sometimes this is useful to set is if you've got a whole lot of maps that the maximum is different, but you want them all to be coloured in the same way, you define the min and max so they're all the same. Rather than if it's automatic, it will pick the appropriate max for that map, but then you'll get different colouring to other maps. So our colour map, this is matplotlib, and we're going to use Inferno. And let's have a quick look at colour maps. All colour maps in matplotlib, if you end it with _r, it flips it around. So if I didn't have this r, it would go from black to yellow here. So, but I can matplotlib color maps, because it's American. Mind you, it would, I'm sure it would find it if we spelt it in the English way. And then if we look at, we've done a search, images, and here are the different colour maps that you can pick from. So this is often the easiest way to do it. Can't guess, there's a lot of them. So in here somewhere should be Inferno. I won't try and find it. It must be in there, unless it's not listing them all. But it'll be in one of these others. So these are the maps that you can use. It just colours them in a different way. We found colouring strangely, perhaps not strangely, important or contentious, if you like. You can choose colour maps that exaggerate differences between different regions. This one is pretty dramatic. You can choose colour maps which are less dramatic, maybe make the differences not quite so in your face. So colour maps can actually affect how people interpret and see the maps. Well, let's pick another one. Let's pick blues. Colour map equals blues. Okay. So you could argue that maybe it's not quite so dramatic of the differences between them as we had in Inferno, and then we reversed it with the _r. Okay, yeah, I think that's sort of more dramatic. So it can be used for good purposes or perhaps for bad. You know, you could have things just subtly shades of different grey if you wanted to hide differences, or something dramatic like this. There's also, let's have a quick look, there are even more, perhaps more dramatic ones. Let's just do one more. Let's do rainbow. Yeah, that's arguably even more dramatic. I seem to remember we picked this once and then were asked not to use it again, please. So let's have a look. We were Inferno and then reversed. Let's just quickly do that. Okay. Right, so the next one is, don't worry too much. I had to Google and find kind of, well, let's do it without. This is the sort of thing that you copy and paste from one thing to another. If we do it without these legend keywords, we get that. It's actually used the full length here when I didn't want it to, and it's not very good. So I could fiddle around with this fig size, or what I did here was just used legend keywords. So we're passing a dictionary, and I'm going to shrink it by a certain amount, and I'm also going to give it a label which I want. So that's done by passing a dictionary of optional arguments to the plot method. There's a few things in Matplotlib where you pass a dictionary, so let's put that back, and then set to display legend. Can't remember what happens if we don't have that. I guess we wouldn't have the travel time. You can try that. Then I set the axes to off. If I didn't have that, it would plot it more like a normal chart with our Eastings and Northings on. But if we want it to look more like a map, we turn that off. And then I save it, and I'm going to save it as a JPEG, and I'm going to say this is an optional argument. DPI dots per inch is 300, so this is going to produce a very high quality map, or high quality. You can take that up to 600 or more. And then plot show just to finish it off. Okay, so that's our map. Okay, we're going to take that and we're just going to add a couple more things. Now let's have a look at it first. Let's run it and then see what it produces, and then go back over the code and have a look at what we've added. Remembering, don't think you have to remember all of this. These are examples that you can just copy and paste from. Okay, now we've got our LSOAs as before, and now we've added points where the hospitals are. We've given them labels, which are the postcode names in this case, and we've added a base map which comes from OpenStreetMap. And nicely, it automatically puts the copyright on. OpenStreetMap, you are free to use and publish in whatever way you want, but they ask you to put the copyright on, which is fair enough, really, because nobody's paying for this, so it gets them some credit. So what have we added? I just noticed we've got slight lines around LSOAs because I think we probably haven't got our anti-alias on. So I'm going to copy that down. Find out now there was a reason why I didn't have it. It doesn't matter the order in which you put these, by the way. Right, this is as before, except here I've used line width to hide the border lines. I wonder why, if there was a reason that I didn't use the anti-alias. Anyway, we'll find out. Everything else is the same, except I've added a transparency, and it reveals the base map underneath. So if I had alpha, I can never remember which way alpha goes, whether alpha of 0.9 makes it very untransparent or very transparent. Again, play with these things and see what it's like. So that is as before. Now and this is generally in Matplotlib, you can plot another chart over the top of the original using the same axes. So now we're going to plot, that was plotting our LSOAs, now we're going to plot our hospitals, and we just tell it ax is equal to ax, tells it to share, all of them are going to share this axis here that we've defined. It just means they're going to all pile up on top of each other, superimposed, our LSOAs, our hospitals, and our base map. And here we're going to give it a, what are we going to mark it with? These are plotting points. We're going to mark them with asterisks. We give it a size, a face colour, and an edge colour. Or this is a star. So face edge colour K is black in Matplotlib. Face colour is white. Now we're going to add labels, and again this is a one that you're probably not going to remember, so just cut and paste. You can kind of work out what it's doing here. So you would just copy that and adjust it if you try adjusting things if you want, and see what it does, and then try it on other maps. So that adds our labels, and now we're going to add a base map, and this is contextually. This is where contextually comes in. Contextually is going to go out to a map provider and get a base map for the area that you're looking at. So you do need a connection to the interwebs at the time that you're running this. So contextually, CTX, add base map, which is a method of CTX. We give it the axis that we're going to want to plot over. We pass it the coordinate reference system that we're using to make sure it's all kind of aligned. And then we give it its source. And if you want to use OpenStreetMap, the most common one in that is to use Mapnik, then this is how you do it. And most of the time you will just do that. Zoom adjusts the level of detail in the base map. I can't remember what its limits are, but you can sort of try changing that between sort of 1 and say 20 or 30 or something like that, and see what it does. And you can adjust it to, do you want a lot of detail in your base map or not much? Spurious text added there, and then the rest is pretty much the same. So we've got some extra stuff in here, which again you will just copy to adjust for printing, and we've added a title. So, and these you can kind of have a play at again if you wanted to see what it all looks like. Often these use a template, copy and paste, and then adjust for your map. And then we're going to save our figure again, DPI 300, and then show that. And that, well, you've already seen. Oh, except we've added, turned back on anti-aliasing. Ah, now I remember why I turned it off. It's something to do with anti-aliasing loses the transparency value, and I didn't find a way of getting around that. Let's do that sometime. So let's run without the anti-aliasing. And that's saved in saved as map. And then we can look at it also in thought we could look at, yeah, Matplotlib. You can see here actually the setting the line width has effectively removed the boundaries, but they are ever so thinly visible at this point, the boundaries between LSOAs in with the same colour there. So they are still, actually no, they're different colours, aren't they? That's coming up. Oh, they're two areas that are the same colour, and we can see just about the boundary between them, so it's not completely eliminated. Okay, so that's taken you through. The next section we'll just pick a different base map. We'll pick one with train lines on, if you're interested in seeing. Also teaches you a bit more about base maps, but I'll put that in a separate section, and it is very, very, very optional. So let's just recap. Let's go back and have a look and see what we did throughout this session. We looked at GeoPandas installation. That was back about a year ago, I seem to think. Then we loaded a standard geographic file format. Shapefiles are most common, and we created a GeoPandas DataFrame with that, which knew its geometry. We set coordinate reference system, and remember there are just two of these generally. There are lat long and British National Grid Eastings and Northings. We created a map from just saying plot the GeoDataFrame, GeoPandas DataFrame. Then we brought in geographical areas, the counties, and we merged those that were in Devon and Cornwall together so that we could then select either other areas, LSOAs, that were within our defined area of interest, or our hospitals. We could select just those hospitals within our geographic area of interest. During that process we had to do a quick bit of conversion, but it's very easy. So it's very explicit which coordinate reference system you're using in GeoPandas. And then we brought in some travel time data as well, and we sort of mapped that with matplotlib, pulling them all together and producing our output. So hopefully you see how all this you could easily automate to either run the same thing on the same data, each week, or for us modelling a whole lot of different scenarios. If we've got the data, it can then rattle through them all, bring in the data that it wants, or look at whichever column is appropriate in a table of scenarios, produce a map, give it a name for the scenario as well, and save it. So GeoPandas is great for automated analysis. Yeah, hope you enjoyed that. That's the end of the main session, and there'll just be a quick extra session that I'll do now. Just look at train lines. Okay, very optional extra. Just to show we can bring in other source maps, base maps, this one about railway lines. So let's have a look. Now I've already run this because the database that provides the railway lines tends to be a bit slow, quite a bit slower than OpenStreetMap. So we create our subplot as normal. We plot our LSOAs, and I'm not colouring them by anything now, so it's just a very simple plot because it's all going to be the same colour. I'm going to let it choose the colour. Transparency of 0.5. That's always a good one. You don't have to remember whether a high value is higher transparency or higher opacity. Just go for the middle. Then we're going to plot our hospitals, location of our hospitals as before. We're not going to label them. Then we're going to add a base map, and this time, so we still have to pass it our coordinate reference system, we're going to use contextually provide an open railway map. And we'll have a look at a second of all the different providers that you can get. And again, transparency at 0.5, and show that. Not quite sure about this error message. I need to hunt why that gives it on this one. Anyway, so what we've now got, we haven't got our other base map. We'll bring that in a second because we can have more than one base map, which is nice. So we've got our Devon and Cornwall area, and we've got our train lines coming in, including the critical Dawlish link for all of Cornwall and a lot of Devon, exposed to the elements there. Okay, so all we've done is brought in a different source map using contextually CTX. I'm getting better at saying it. Okay, so now exactly the same, but let's add in another base map. So I've got one base map which is OpenStreetMap, and another base map which is Open Railway Map. I've fiddled around with these transparencies again, but I didn't really optimize them. I just tried a couple of different things, and then equally Devon and Cornwall LSOA's got a low transparency or low alpha. So this is the resulting map. So we've got our Devon and Cornwall. Actually, that's, I guess you can see there with the low alpha, you can only just about see it, the boundary. And then we've got our OpenStreetMap and our railway map in there. And yeah, I think if if you wanted to get that looking good, I think you'd have to sort of adjust the order that you're putting them and adjust the transparencies and to get that just right. But it was just for a bit of fun, so I added that. All hospitals near railway lines. So our providers, and this is just a bit of code I found somewhere on the interwebs. To get the providers for contextually, we define this function. And our providers is going to be set up as a dictionary, and this function will get the providers. And then if we just say providers, we could kind of loop through it in some way, but so this lists them all, and you can see there are actually an awful lot of providers that you could sort of have a go at and just see what do they bring in. Though some of them, I mean, OpenStreetMap DE, presumably that's just for Germany, would be my guess. And then you've got France and different ones. So these are all the different providers. World physical map, terrain, world imagery, topography. Some interesting looking stuff here. Ocean base map, that sounds fun. And you just sort of try this open weather map. I haven't tried any of the others apart from OpenStreetMap is the one we use a lot. And I thought, pull in the railway map. But you see it goes on and on and on and on and on. So worth just having a look, playing around. I'm not sure if all of those are completely open. I haven't tried them. Some of them may be closed unless you have a license key. I just don't know. Right. Hope you enjoyed this whole session, and go away and have fun. What I suggest you do is take some data of your own, or use the police data we used in QGIS, and just have a play with mapping. Always best to have your own kind of project to do to learn these things, I think, and then bring in stuff from elsewhere and just get it working. You know, expect bugs and problems as you go along and work out what they are and fix them and get something working for yourself. Okay, goodbye everybody from GeoPandas world.